Erik Darling here with Darling Data, and we're going to talk in today's video, continuing on with our series about how to write queries correctly. And this, of course, comes down to two things, like both getting an accurate, correct result, according to the logical demands of the query, and also having it return data to you in as efficient a manner as possible. And today we are going to talk about union and union all, or as they say in the South, union y'all. All right. If you can forget that joke happened and you would like to support this channel, not for the jokes, but for the SQL Server information, or if you like that joke, you can just do it for the jokes too. I don't care. Whatever your motivation is fine with me. There's a link in the video description where you can become a member of the channel. If clicking that link is too hard for you, perhaps clicking other things you'll find a little bit easier. Liking, commenting, subscribing, all wonderful things to do. If the topics in these videos are near and dear to your heart, and you're having SQL Server issues that you think a young, handsome fella like Erik Darling from Darling Data could help you solve in exchange for money, I am available for hire for any and all of these things. You have a great time with me together, one-on-one, solving all sorts of stuff. Training, good to have, better to watch. I had someone email me and say, hey, when I go to your training site, I can't add anything to the cart, and I can watch all the videos. Did I buy this before? And so I went and looked in my receipts drawer, and lo and behold, they had purchased the training in December of 2020. So I said, yes, you did purchase this. Just like on the cusp of 4 years ago. Training works best when you actually watch it. It's a participation sport. You have to be involved. Otherwise, you still know nothing. No upcoming events. 2025, talk to me. Tell me where to go. I don't know where you are or where you want me to go. I'm not endowed with psychic abilities, though I wish I were. So you have to tell me where you would like Erik Darling to be. With that out of the way, let's talk about union and union all. So union and union all are funny because they kind of get used interchangeably in almost the same way that a lot of other things are, with very little consideration for like performance or result correctness or other things. So like common table expressions, temp tables, table variables, parameters, local variables, all sorts of things that joins and exists. People just start writing a query one way and then they just always write the query that way. I remember a long time ago I read it. I used to play drums when I was a kid, and I was reading an interview with a drummer in some drummer magazine, and he was like, I was playing in this cover band, and we were like, it was good because it was very, very successful cover band, but every time I sat down to play drums, the only thing I could think of to play were like the drums to these cover songs, and I was like, wow, that's depressing. And then I realized, wow, that's how people write queries too. They sit down and they're just like, I'm gonna play Copacabana again, I guess. So there are lots of times when I see developers use union, like when the results have absolutely no chance of having duplicates in them, they either like join different tables together or have different where clauses, or sometimes they even have like literal values in the select list that are just like, how can you make those distinct? How can you do that? It's weird. You already have distinct in the select. How are you going to make it more distinct? And a lot of this stuff comes from testing queries in isolation, not really knowing that when you should use exists first joins, because they haven't watched the other video in this series about exists and joins. And once you start getting other things involved, like no lock hints, you could just end up with crap everywhere. Right? Just bad things popping around everywhere. Now, how to write queries correctly does depend on a number of things. The quality of your data in general. B, the quality of the data structures that you have available. That largely means the indexes. And also, what returns a result to you as quickly as possible that is still logically correct. This can all become really difficult to figure out. Especially the more complex a schema is, the more things you have to get involved, the more calculations you have to do. Knowing what I think that really the hardest part about writing a query, aside from knowing like the SQL behind it, is knowing what the correct result should look like. That's a very hard thing to define up front. You have to like write a query, get a result, and probably show it to someone who can be like, yeah, I don't know either. Probably, I guess it's right. Seems fine. Validating query result correctness is a challenging thing. I'm happy when my rewrites just match what the slower query returned. I have no idea if that's right or not. I'm not checking that. I'm just making sure that the same number of rows and the same data output is. It's as far as I usually go, because I don't usually get involved enough to like dig deep into like someone's data and understand what an actually correct query result would look like. There was sort of a funny story where there was one client of mine who had a very slow recursive CTE, which I helped fix up. And the original version of it would just never return a result. It wasn't like an infinite loop thing. It was just slow as hell. And when we got it right and we sped it up, they were like, I think the logic in here is wrong because these results aren't correct. So we had to like redo the recursive CTE because they were like, yeah, this isn't showing us the correct thing. So that was fun too. So let's use a rather nifty SQL Server 2022 function. So let's start talking about union and union all and how they differ, and actually union and distinct is what we're going to talk about first. So I'm going to, you know what, I think actually I already did this stuff. If we look at these two query plans, there should already be stuff in these tables. Yes, there are. Okay, great. So we have two queries here. The first one says select I from T1, union select I from T2. The second one says select distinct from T1, union all select distinct from T2. The thing that I want to show you here first is, of course, the results. We get very different results back. The first one just returns 1, 2, 3, 4, 5, 6. The second one returns 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. So even though we had 1 through 5 in this table twice and 1 through 6 in this table twice, these queries made different things unique at different points. If we look at the query plans for these, the union query adds its distinctness at the end across both result sets. So we not only deduplicate the results from each table scan, but we deduplicate the entire result here. For the two distinct queries, the distinctness happens here, not at the end, right? So when we say select distinct from this one, select distinct from this one with a union all in the middle, we make this distinct and this distinct, but we don't make the final result distinct. We just spit back whatever these two things put together. So distinct and union all do make distinct and union do make different things unique. Most of the time, if you are using union, rather all of the time, if you are using union between two queries, you don't need to also add distinct to the select list because you're already going to get that at the end. You might just be doing weird extra work. Another thing that is kind of fun about is about union and union all placement in a query. So if we look, I should have highlighted the whole thing, shouldn't I? If we look at this and we look at the query plan, we just get a constant scan. If we were to quote any of these things, then it wouldn't make a difference. But if we start changing these, we will start seeing slightly different results. For example, this one removes an extra 1 and 2, or sorry, removes an extra 1, but we still have 2 2s and 2 3s. I think the execution plans for these are just kind of funny because we have two constant scans and a distinct up here, but then just a concatenation for the other two things, which are down below this. If we quote this one out and this one in and run this, the execution plan now has this with a distinct over here, right? We have a constant scan, concatenation, constant scan, concatenation, and the results are 1, 2, 3, 3. So we have removed some additional, we have removed that extra 2 from the query results. And of course, if we put the union down here at the very end, we will see a slightly different query plan and a fully deduplicated result set. 1, 2, 3. We look at the query plan for this. We have one constant scan, and then the deduplication at the end, just like with the query where we selected from the temp tables. So that's fun right there. Now, there has been quite a lot of performance talk about union and union all over the years. Well, I do agree that most of the time, as long as you get correct results, union all is going to be a bit cheaper on you because SQL Server will not attempt to deduplicate the result sets. Even attempting to deduplicate unique result sets, if you have a bunch of string columns involved, can be rather painful and unwieldy. If you are in the habit of writing union queries, or even putting distinct in your select list, I would really strongly encourage you to think about the number of columns you're selecting, the data types of those columns, of the columns you're selecting, and what actually identifies a unique row. Because you might be, doing distinct over a bunch of columns where it's not making a difference. You might be doing union over a bunch of columns where it doesn't make a difference. Oftentimes there is a sort of hidden subset of columns in your data that you can make an easy sort of distinct result set from without having to worry too much about it, without having to worry about long select lists and stuff. So if we run this and we look at the query plan that comes back, this takes about 2 seconds. This is not a terribly dramatic example, I admit it. It's okay, but the thing is that we're doing select all this stuff and including this text column, and this is in varchar 700, and now you have to worry about deduplicating that. If we were to take this query and do this, and what we would be doing is taking the same base query with the same columns in it, but then only generating a row number over the columns that we know make a unique result set, this is a little bit faster, right? Like I said, this is not a terribly dramatic example. That's about 400 or so milliseconds faster, but it's still a good example of how you can improve things by thinking a little bit more analytically about your data and what you need to make unique and what you don't, right? So, like in this case, generating a row number over these two union all result sets is a lot faster. Now, when I said most of the time, I do mean most of the time. There is less overhead to union all over union, but there are some cases where it does make sense to make a unique result set to make some other operation in a query plan more efficient. I want you to think of this sort of like pushing predicates down to when you touch tables rather than having a filter operator happen later. That's something that I talked about in the exists versus joins video, where I showed you a query that uses a left join with a where clause to find rows that don't exist in one table that exist in another table, and how using not exists was much more efficient in that case because we joined less data together, right? Because with the left join thing, we had to fully join both tables and then filter out nulls afterwards. The same thing is for like pushing any predicate or reducing rows as much as possible before you do something that is computationally expensive in a query. So sometimes getting a distinct set of rows for your query can make things a lot better. So what I'm going to do now is populate this temp table with user IDs for people who have won these badges. And the first way that I'm going to run this query is with a union. And we're going to marvel at the query plan for this. So this takes about, let's see, 5 seconds right there, right? And, you know, this would get better with, you know, slightly better memory grant, stuff like that. If I ran this like multiple times, you would see it get a little bit faster because SQL Server, since I'm in compat level 160 for the other stuff, we're getting memory grant feedback. So this would improve over a few runs. We would eventually see that spill kind of fall off. Usually it's like 3 or 4 runs before the spill goes away. But anyway, now what I want to do is change this to union all. So now we're going to be taking, like before with union, we were deduplicating these results, right? We were getting rid of them. But now when we do this, what we're going to notice is that this query no longer finishes in like 5 seconds. This query drags on for a little bit longer. And by a little bit longer, I mean this thing is going to run for about 30 or so seconds total. It's been a while since I timed this one, so you know, who knows? Maybe you know, Intel gave me some supercharged boost to my CPUs, and maybe it'll finish a little bit quicker. Maybe not. I don't know. We're just gonna let this thing ride. And we're at 35, 36, 38. Oh, we're at 40 seconds now. Well, I don't know. I think this might be proving the point a little too well. So we got up to almost 50 seconds on this one. We got 47 seconds, and that's because rather than and you can see that like the pain of this wasn't even in here. Like there was almost no overhead to like doing the concatenation of these. We did still have to, you know, do all this stuff in the sort and whatnot. But where this makes the biggest difference is the number of rows that end up, or the number of things that we end up doing in the table spool, right? So we have a nested loops join here. SQL Server uses a table spool here. I've talked about table spools in the past, but they are sort of interesting. SQL Server uses them on like for in select queries, not in modification queries. Modification queries, spools are for Halloween protection. In select queries, spools are often there to optimize operations on the inner side of nested loops. By the inner side of nested loops, I mean this portion of the query plan in here. So a table spool is fun because a table spool, you know, you take sorted data from this table, right? You sort it here, and then you pass it to the nested loops, and the nested loops will, you know, tell the table spool to go run the query for, let's just say, ID 1. It'll populate the table spool, and then for any additional runs with ID 1, it'll reuse the data in the table spool. Then as soon as we get to ID 2, the table spool will get truncated and repopulated, and then it will reuse data in the table spool for ID 2 until we hit ID 3. So table spools really can save a lot of time and energy on the inner side of nested loops sometimes. But in this case, the problem is more that we end up with way more stuff to do with because we don't deduplicate results here the way that we did with the union query. So if we go back and we quote out the all here, remember this is about 40 something seconds, and we run this. We'll do this one more time with the union rather than the union all. It should be about 5 seconds or so. And we get the results. Notice that like, you know, we do the same thing where we, you know, concatenate the results, but then before we send it along, we use a distinct sort to make the results of these two things distinct, and we spend a whole lot less time in this portion of the query plan. Right, so this part does a whole lot less work because we made the result set unique in this part. So you can run into interesting situations where using union to deduplicate results makes a computationally expensive part of a query faster, or a repetitive part of a query faster. In this case, the nested loops is really what did it. So that's a pretty good way of thinking about things sometimes, where can I make this part of the query execute fewer times or do less work with a distinct result set rather than a non-distinct result set. So anyway, that's about all I have to say about union versus union all. As always, I hope you enjoyed yourselves. I hope you learned something. I hope that you will continue watching this series. I hope that you will continue to write queries correctly. And I will see you over in the next video, which is going to be about two things that I never see anyone use. Intersect and accept. Fun times. Oh boy. You're going to get a relational mouthful on the next one. So I will see you there. Goodbye.